Hello guys, this is the fifth video of the chapter Amines. Till now we have studied the basicity of amines, and then we started the methods of preparation, in which we studied alkylation of ammonia, NH3, fine, NH3. This was the first method. After that we studied the second method of preparation. This was the first method. After that we studied about the second method of preparation, and that method was Gabriel synthesis. After that we studied about Hofmann reaction or Hofmann rearrangement reaction, fine. And now in this video we'll be studying about what we call as reductive amination or amination, right? So in the first video we saw there was a drawback, that we got a mixture of this and this amine, that is primary, secondary and tertiary amine, right? We got a mixture and it was very difficult to separate them from that mixture. As a result of which we needed an alternate method of preparation, and for that we switched our ways to Gabriel synthesis. In this method what we did was we prepared primary amines only, and we started the reaction with the phthalimide molecule, which looks something like this. Let me draw that for you. And this is the, just a moment, and this is a lone pair, this is H, here this is the phthalimide molecule, fine. This is what we started the reaction with, and we ended up in primary amines, fine. Now then we studied after that Hofmann rearrangement reaction. It also yielded us, let me change the color of the pen, it also yielded us primary amines only, fine. And those primary amines, they were, and in this reaction starting material was RCO NH3, that is an amide, right? Fine, NH3, NH2 here only, fine, an amide. So these reactions generated only primary amines. Now what if we need to generate any amine we want? For example, we want to create a primary amine, so we'll be using this reaction. But what if we wanted to create a secondary amine, or what if we wanted to create a tertiary amine? So you will be saying that we'll be using this reaction, but in this process then their separation would be a task for us, because it will not produce only secondary and tertiary amine, it will produce a mixture of three, that is primary, secondary and tertiary. So to counter this, we have a reaction that's called as reductive amination. This reductive amination, it provides us, it empowers us, to create any amine we want, be it primary, be it secondary, or be it tertiary. Whatever we want, we'll be starting with a particular reagent in this, a particular reagent in this, and a particular reagent, I won't say reagent for being appropriate, particular reactant we will say. We'll be using a particular reactant for this preparation, for this preparation we'll be using a different reactant, and for this reaction we'll be using a different reactant. Let me say you, this empowers us to create the amine, whatever kind of amine we want, So now let's try to see the mechanism of this reaction. Let me say you, in this reaction, in alkylation we used Rx as starting material, right? In this we used this, and then we added Rx in the second step of the reaction, if you remember. And in Hofmann rearrangement we used this molecule. Now comes the turn of the reductive amination. In reductive amination we use a ketone, an aldehyde, or a ketone, fine. Let me write it here, ketone, fine. We use either an aldehyde or ketone. If we use an aldehyde, then we use a molecule like this, This is an aldehyde. And if we use a ketone, then we use a molecule like this. This is the ketone. Fine. Now, what we do is that we get a primary amine, a secondary amine, and a tertiary amine, depending not upon if we use ketone or aldehyde, but depending on the next reactant that we take, depending upon the amination we do with. If we do the amination with, let me erase this thing here. If we do the amination with for NH3, that is ammonia, and then do reduction using any reducing agent like sodium borohydride, so we get a primary amine. This should be noted, right? But if we use, instead of NH3, we use N or double dash and H2, fine, then followed by reduction again, then we will be getting secondary amine. Fine. Now if we use N or double dash or triple dash and H and followed by reduction, then we will be getting tertiary amine. Fine. These are the three criteria based on which we get either primary amine, secondary amine, or tertiary amine. Now we get a primary amine if we use ammonia for amination. We get a secondary amine if we use a primary amine for amination, and we get tertiary amine if we use a secondary amine for amination. Here you need to focus on it. It might be a bit confusing, but you got to focus on that, right? So this is what we get. Now let's see the mechanism of the reaction, how the reaction proceeds. The reaction proceeds in the following ways. See what we have. Let's start with the ketone here, R, C, double bond O, and here we have R double dash, fine. This is a ketone. We can take an aldehyde. If we don't take R double dash here, we take H instead of this, right? So then it will be then an aldehyde will be formed, and we will be getting the product, but both of them will generate the product based on this. I know different products will be generated, but the degree of amine produced will not be changed, right? So here we are focusing primarily on degree of amine, so let's not take into consideration the effect of this R on the molecule. So let's do that. Let's not do that. Let's just consider, and let's just make focus on the degree of amine, right? So if we add, let's first prepare a primary amine through this reaction, right? So if we will, in the preparation of primary amine, we will be taking NH3, fine. Here it is NH3, and now this NH3, what would it do? Let me erase some things from here. Fine. Now also let me erase this because it is R dash, fine. It's R dash. Now what would do this lone pair on this nitrogen? It will be attacking this carbon. This will go up. What we'll get? We'll get something like this: R C O, sorry, R C O H. Here is R dash, and here is N H. I'm elaborating it because I have to show you the removal of hydrogen from this molecule, because this will be positively charged, right? Now what happens is that, sorry, there is no H on this molecule. I don't know why I have written this. There's a negative charge though. Let me write it down. Here it is, oxygen with a negative charge, fine. Now what would happen is that this nitrogen, as it has developed a positive charge, it will be taking this bond pair, and this hydrogen will be released as H positive. This oxygen will capture it by donating its electron pair to it. So what we would get is something like this: R C OH. Now we have got OH. All right, fine. R dash, and here we have NH2. Fine. This is the step. Now here we need to know that this amination has completed. That is, amine group is added already, so amination is completed. Now we are to follow it with reduction. It's the first step. It's the first step. So this one will be the second step, right? Now let's go for the reduction. That is, we add sodium bromohydride to it, sodium borohydride to it. Sorry, bromo. I don't know why I said bromo, but sodium borohydride to it. That will be furnishing this H negative. Fine. H negative. Now this H negative will be attacking this carbon. Fine. And this OH, it would be better to say that, let me just erase this. In the medium there will be HOH, that is water. Fine. This oxygen, it will be donating its electron pair to this hydrogen, thus taking it away, that is H positive. Let me show it here on this oxygen. Fine. So it will be having OH2 and a positive charge. Fine. Now when this H negative will be coming, this will be leaving and taking this bond pair of electrons with it. Fine. So what will be left is R, C, there's an H, fine, there's R dash, and there we have NH2. So this is the primary amine. Now I know many of you will be confused. There are two R's, this R and this R, but let me say to you, a primary amine is one in which only one alkyl group is attached to the nitrogen, right? So here only one alkyl group, that is this alkyl group, is attached to nitrogen, and the rest two molecules attached to nitrogen are these H2. So this is a primary amine. Now if this R, if we took a ketone instead of S, if we took an aldehyde instead of this ketone, then what we would be getting is something like this: R, C, H, and this is H, and H, and then NH2. This, most of you will be familiar with this form of primary amine, but let me say you, this as well as the primary amine. So this is the primary amine that's formed as a result of reductive amination, in which we intended to prepare a primary amine, so we used this NH3 molecule. Now in the second reaction, we'll be preparing a secondary amine. So to prepare a secondary amine, you should be knowing that we'll be using this molecule, right? Now let us do that as well, because I think it's better to do it now. The tertiary, you will be working that out on its own, on your own. That will be also with the same mechanism. You can now, I think, draw the mechanism for secondary amine formation, but let me show that to you. After that tertiary, you will do that on your own, because or else this video will go too long. Let me now show you the formation of secondary amine, right? So here we have R, C, double bonded O, then we have R dash. Fine. So now this time we'll be adding primary amine in order to produce secondary amine, right? Yeah, you should be knowing that. Then here we have H2. Fine. Again the same process will happen. There's nothing different in this. Here this will go up, right? I hope you understand it. We'll be getting R, C, O negative. Fine. Here will be R dash, here will be N, here will be two H's of this primary amine, right? And here is the R double dash. Fine. Now what would happen is that this N has developed a positive charge, so it will be withdrawing these two electrons and taking them from this hydrogen, as a result of which this oxygen will donate its electron pairs to this hydrogen. So what we will get is R, C, all right, OH, fine, and here we have R dash, here we have N, H, and here we have R double dash. Fine. Now again reduction will take place. We will take sodium borohydride, that will give us H negative. Also you can say this H negative goes here, this OH negative leaves and form and combines with H positive to form H2O, right? So what we'll get is R C. All right, here will be H, here will be R dash, here will be N, here will be H, and here will be R double dash. So here you can see now a secondary amine is formed. Why? Because a secondary amine is one in which two R groups are attached to nitrogen and one hydrogen is present, right? So here you can see this is one R group and this is the other R group present on the nitrogen, and this is the hydrogen. So what we got is a secondary amine. If we took aldehyde instead, let me not erase secondary. If we took aldehyde instead of ketone, then what we would be getting is, let me draw it with yellow pen again. If we took aldehyde instead of ketone, then what we would get is something like this: RCH2 NH and R double dash. Fine. This would be the product in case we took ketone. Fine. So here you got to know about the formation of secondary amines. In the same way, tertiary amines will be formed, where here you can see in this form at the formation of tertiary amines, we'll be taking a secondary amine. So instead of this H in a secondary amine, we'll be having something like this over here. Let me now elaborate that to you as well. All right, we'll be having R triple dash here. Fine, and this will be the tertiary amine formed. That is in case we took R. That is in case we took R double and R double dash, R triple dash, H. Fine, but we didn't do that here. So what we got is this product. Fine. Hope you understand it. Make sure to subscribe to the channel Chemistry Crux in order to get more videos like this on topics of chemistry. Today we are in this playlist we are completing amines. After this we'll be taking any other chapter. Make sure to subscribe, and thank you very much.